In this video, we're going to look at compound interest. Identify the givens and the goals in each problem and write your final answers as complete sentences. So Riley invests $7,000 at 3.4% interest compounded monthly for 8 years. Okay, so that's a lot of given information. Next, we're asked the question, how much is in his account at the end of the 8-year period? We want to know how much interest he earned and what percent of the original amount is interest. And we're going to round our results to the nearest cent or 2 decimal places. So let's figure out what our given values represent in terms of this formula. So this is the formula for compound interest. P is the principal, A is the future amount, R is the annual interest rate, N is the number of compoundings per year, and T is time in years. So this exponent, N times T, would be our total number of compoundings, which we're going to compute along the way. So first we have the principal, $7,000. Our annual interest rate is 0.034, written as a decimal. We're told that it's compounded monthly, so that would be number of compoundings is 12 because there are 12 months in a year, and T equals the number of years, which is 8. Now in addition, I'm going to compute N times T, and this is the total number of compoundings over the life of the investment. So it's better to do this now because it's easier and then we don't have complicated things in our exponent. So 12 times 8 is 96. And we'll put that right here. Okay, now let's plug in what we know into the formula. So we have A equals P times 1 plus R over N to the NT power. Okay. Now we're solving for A. We know P is 7,000. We know R is 0.034. The number of compoundings per year is 12, so we divide by 12. And then instead of putting N times T, I'm going to put our result that we already found. We're going to raise this to the 96th power. Okay. Now, if you have a scientific calculator or a graphing calculator, you can put this in one big step or in one big line. Okay. We're going to do this in a few pieces for the computer calculator. First, we're going to do this. So we're following the order of operations here. So first you do what's in the parentheses. Next, we'll raise it to the 96th power, which is the exponent part. And then lastly, we'll multiply the result by 7,000, which seems weird since the 7,000 is out front, but that's our order of operations. And this is also going to show us along the way some of the meanings behind these values, so I want you to see it this way as well. We're not going to round, we're not going to put intermediate values, because you can get round off error. So never round until the very end. So let's see what we got. Okay. Now first the part in the parentheses. Okay, remember our 1 represents 100% of the principal. And now we're going to add the interest rate, 0.034 divided by 12. Okay, and this piece here is what we call the periodic interest rate. So since we're sharing this yearly interest rate over 12 months and 12 pieces, this amount right here, this decimal, is the interest we'd get per month, and the 1 represents the 100%. Okay, now we're going to raise this result to the 96th power. So that's going to be the 96 compoundings, and there's a button right here. It says X to the Y. Notice it put a little caret, and now I'm going to put 96. So I like this value because notice we're going to multiply this, okay, by 7,000. So this actually tells me the future value and how much interest we're adding on as a percent of the principal. So the 1 is representing 100% of the principal, and this long thing, okay, is representing how much interest will be added on. So it'll be 31.21%. Okay, we're going to find this another way too, but I like to see this as I go. And now we're going to multiply this result times 7,000. Okay, now we'll round, and we get $9,184 to the nearest cent. We'd round up to 58 cents. So 9,000. So there's our final future amount. Now the next question we're asked is how much interest does he earn? And we can compute this just like we did before. Okay, the interest, if we have the amount and the principal, we can just find the difference. The future amount minus the principal. So 9184.58 minus 7,000. And let's just do this in our head because this is a nice number. So it's going to be $2,184.58. Okay. Now our last question. We're asked what percent of the original amount is the interest. Okay, and we found this before by dividing the interest, that's I for interest, divided by the principal, and we multiply by 100% to write this as a percentage. Okay, now the interest was $2,184.58. We'll divide by 7,000 and multiply by 100 to get the result as a percent. Okay, and we actually saw this along the way, but there's no harm in doing it this way. So 2184.58 divided by 7,000 times 100. Okay, and we'll round to 2 decimal places. So there's an 8 in the thousandths place, so I'll round up to 1. So it's 31.21%, which should look familiar. Okay, so we've answered our 3 questions, so now let's write our answers as complete sentences. So I tried to make a little room here. So the first one was how much is in the account at the end of the 8-year period. So our answer is there is $9,184.58 in the account. Now our second question is how much interest does he earn? And we found he earns $2,184.58 in interest. And finally, what percent of the original amount is the interest? And that's what we computed here. The interest is 31.21% of the original amount. So again, remember why this is useful. Okay, we know we had this interest rate of 3.4%. In the end, after the compounding in 8 years' time, okay, we get a total of 31.21% of the original amount.